To another Ekos focus video. This time I'm going to talk about adaptive focus. So I'm going to start off by, I think, just spending a few minutes explaining what adaptive focus is designed to fix or improve. Then I'll spend a bit of time explaining how I set it up on my rig. Not necessarily suggesting that the way I do it is any better than any other way, but it might just give you a little bit of an insight. And then I'll do a quick demo of adaptive focus actually being used. So again, I'm just using the simulators on my laptop for this video, so I've got a bit more control over what's going on rather than trying to do this whilst an imaging session is underway. So back to the purpose of adaptive focus. So taking a step back, we're all kind of used to setting up our rig, focusing it, taking some subs, focusing again, taking some more subs, focusing again, and repeating that through the night. So thinking about why do we need to keep refocusing, it would obviously be great if we could just focus once and that would be it, because then we wouldn't have to spend all this time sort of refocusing, and we could spend more of that time imaging. I think the reasons for having to refocus break down into a couple of categories. So first is we've done something to the optical train that has caused the focus point to move. So the most obvious one is you've changed the filter. Your filters aren't parfocal, and therefore the focus point with the new filter is different, and therefore it's necessary to adjust focus. I'm not going to talk about using offsets in this video. I'll do a separate video on that, but a way to not, in that particular case where you've changed filters, a way to not have to do a full refocus is to use offsets. So that scenario can be dealt with. So I'm not going to say anything more about that. So the other major reason why your focus point will be moving through the night is environmental. So there's not much happening with the target, which is obviously many light years away, that's causing you a problem. What's happening is once those photons enter into the Earth's atmosphere and come in through your telescope to your sensor, the environment surrounding your telescope is going to be influencing the focus point. So what can we do about that? So I think generally people would sort of understand that temperature affects focus point. So that's obviously one characteristic. As your temperature throughout the night changes, so the focus point will change. There could be other factors as well. So if you're shooting let's say at the start of the night, near the zenith, and the target you're following goes down towards the horizon, you will be shooting through more atmosphere. The atmosphere itself may be changing. There could be many things going on. Maybe you've got some sag in your scope that is affecting the focus point. So there's many sort of reasons why shooting in different parts of the sky could theoretically affect your focus point. So I suppose the two things that the Ekos adaptive focus functionality can attempt to compensate for are changes in temperature and changes in the altitude of the target that you're imaging. You don't have to use both of those. You could just use temperature, which is typically actually what I do. But if you wanted to configure your setup for both, that's fine, or you can configure it for one, or you can obviously not use adaptive focus if that's your preference. So what does it actually do then? So adaptive focus will shift the focus point between subframes with a view to trying to keep as near to focus as possible. So what it will do, if we concentrate, for example, on temperature, it will have a model of how the focus point will change with temperature, and throughout the night, as you take a subframe, it will look to see how the temperature has changed since the previous subframe, and based on how you've set up your configuration, it will then adjust the focus by a few ticks to put you back, hopefully, into perfect focus. So if you have it configured correctly, I would say that there are two theoretical advantages to adaptive focus. The first is that all of your subs will theoretically be nearer to perfect focus. So if you're used to the setup, which most of us have, which is you refocus every hour, or with every 1 or 2 degree change in temperature, obviously what's happening there is you run an autofocus, and your first sub should be pretty close to perfect focus. Your second sub may have drifted off a bit, and by the time you come to the end of the range that you've set up, let's say it's you refocus every 1 hour, when you take your last sub before the refocus, potentially your focus will have drifted away a bit. You refocus, everything's nice and back to where it should be, and then off you go again. With adaptive focus, the idea would be that you would be closer to perfect focus with all of those subs, which theoretically would be a good thing. So that's the first advantage. The second advantage would be if you do manage to set up adaptive focus and gain confidence in it, you could theoretically refocus, do a full auto refocus less frequently. So that would mean you would spend more time imaging and less time focusing. Now you don't have to do that. Autofocus is an additional tool that runs in parallel with the current tools that Ekos provides for refocusing. So if, for example, you refocus once every hour and once every 1 degree centigrade temperature change, you can still do that. But in addition, you could turn on adaptive focus, and it will try to keep your focus point nearer to perfect focus for each of the subs, but you can then still refocus as you always have. So you can add this in, see if it works for you. If you don't like it, you can stop using it. But you can still have your full autofocus runs, as you have today. But theoretically, were you to get to the point where you have confidence in the adaptive focus routine, what you might then do is you might start to refocus less frequently. So you could say, I'll go every 2 hours, or I'll refocus only on a 2 degree centigrade change, for example. And I'll show you a little bit later how you might check how adaptive focus is performing for you. So they're the theoretical benefits. Obviously, the other side to those would be, well, it's great being, 1 or 2 ticks nearer to perfect focus, but does that actually make any difference to the sub? If you've got a 5-minute sub, and are you bound by your focus point, or are you bound by how good your guiding is? And if you're bound by your guiding, then improving your focus by a tick or 2 is probably not going to make any difference. But I think generally people would accept that improving focus and improving guiding are the 2 keys to getting better subs. So I think everyone will have to make their own determination as to whether or not it's worth running adaptive focus on their equipment or not. And I'll be interested to hear how people get on. So they're the theoretical benefits. I'll explain a little bit now how to set it up. So there's a couple of checkboxes on the focus tab on the settings. This main checkbox here called adaptive focus, and then there's another one called adapt start pos. I think I'll start off by just explaining very briefly what this does. So the adapt start pos will change the starting position for an autofocus run based on the environmental conditions and the filter in use. So normally, if this is not ticked, what will happen when you start an autofocus run is it will start from wherever the focuser currently is. So normally that would be wherever it finished its last autofocus run. So that for most people is probably fine, but for some people that's not ideal. So if you have if you have a very fast let's say Rishi Chrétien piece of equipment that is very sensitive to the start position of your focus run, then if you're swapping, for example, from red to blue, you may find that the start position, which was the focus point of red, just doesn't work very well when you try to focus on blue. Now, one of the things you could do is you can tick this adapt start pos, and what that will do is it will pick the last successful autofocus run position for the filter that you're currently using. So in my red-blue example, it wouldn't start from where the focuser had finished with the red filter. It would start from the last good autofocus run on blue. It would then adjust that based on the environmental parameters that I'm going to explain how to set up in a few minutes. So this could be quite helpful for people who want to start their autofocus runs based on the filter that they're using. So that's one sort of use case for that. The other is, for example, if you when you start your imaging session up just after dusk, if you're potentially at quite a temperature that's much higher than was the case when you finished off imaging the last time you were imaging, then it could well be that your starting position is not great for an autofocus run because you may be, let's say 5 or 10 degrees different in terms of temperature. Now, again, if you set up your adaptive focus, this should get you into a better place to start your autofocus run in that sort of situation. So that's the start pos. So you can use this independently of adaptive focus. So if you didn't want to use what I'm about to talk about, which is the main adaptive focus functionality, you can still use the adapt start pos. And if I just bring up the filter settings pop up, what it's going to do is, if you, in my example, you wanted to start focusing on blue, it would look here for the last autofocus solution on the blue filter, and it would start your autofocus run at 36665, and then it would adapt that for the environmental changes that I'll explain in a few minutes. So that's how to do it. This last autofocus solution is automatically populated every time autofocus runs successfully, so you don't need to fill in this column, and that's kind of it. So back to the adaptive focus then. So all you need to do to turn it on is just tick this box, and it will start up in the background. this is just the minimum movement. So if for some reason you only wanted to move if the number of ticks was more than 2 or 3, you can set that there, but I think most people will just leave it at 1. This max total move is really like a dead man's handle in case adaptive focus starts running away. So if the max movement for the adaptive focus in the session that you're running exceeds this number, it'll just turn it off. So as I say, it's more like a kind of a safety device to stop things running away. So I've just set this to a very high number for the purposes of this demo. Okay, so before you can actually use it, or before you can get any sensible answers out of it, what you will need to do is you will need to configure a couple of parameters on this filter settings pop-up. It isn't a huge amount that you need to do, but it is a couple of columns, and it's this ticks per degree C and this ticks per degree altitude. So for the purposes of this demo, I am going to leave ticks per degrees altitude in effect switched off by setting them all to 0. And I'm just going to set the same value, which is in this case is 10 for each of my filters. If you wanted to, if you believe that your filters behave differently per then you can put in different numbers here, but certainly in my case that's not the case. If you are thinking, I'd love to use this functionality, but I don't have a filter wheel, then what you can do is you could just configure the filter simulator, put one filter in there, and you can put your data in against that sort of dummy filter, and autofocus would work fine for you. So although the parameters are associated with a filter wheel and actually with each filter, if you didn't have a filter wheel, you can still use the functionality. Okay, so we need to know what numbers to put in here. So how do we know that? So that's back to where you have to do a bit of work. So here's what I do. So for a little while now, I've been building up this spreadsheet. What it contains is, for my rig, it contains all of the successful focus runs across a number of sessions. And it's basically got the filter, the temperature that was pertinent at the time, the altitude of the target, and then the solve position, which is this column here. So where did I get that information from? Well, obviously what you could do is you could sort of watch the screen and just keep a note. The other way to do it is if you enable focus logging within Ekos, Ekos will write a file for you. So if you go to the logs directory, which, just open that up. Oops. So in a parallel directory at the same level as logs is this directory called focus logs. Now within focus logs it will generate this file, autofocus date time .text. Now if I open that up, what you can see is it has pretty much what I had in my spreadsheet, which is the very basic details of each of the autofocus solutions. So what I normally do at the beginning of or the end of the autofocusing session or the beginning of the next day, I open up this file, I transfer the data in here. I just use Excel's import. It's a comma separated variable file, so it's easy enough to import, and providing the column order is the same in my spreadsheet as in the file that Ekos generates, which in my case it is, I can just tag it on at the bottom. What I tend to do is sanity check the data. So if, for example, I have an HFR that's, you know, in my case more than 1.6, I tend to delete that. So I'm trying to do some sort of quality control on the data. So all I've got here is a simple graph against the data in columns C and D. So I'm ignoring, as I said, sort of altitude for now. I'm just looking at sort of the temperature variation. So all this is a plot of this data. So on the y-axis is focus of position, and on the x-axis is temperature. So I've put a line through that. So, you know, I could, for example, you know, use Excel to put different types of fits to it. So for instance, I could put a quadratic through it, which kind of looks like it fits slightly better. But, you know, looking at the R squared, it's 0.85. It's interesting. Doesn't look like that's updating. Anyway, the way Ekos is currently built is it's really after a linear fit. I think it would be quite simple to extend this to, you know, a more complicated fit, you know, quadratic or something if there's demand for it. There is a reason I kept it as a linear fit, which I think is, you know, principally it fits my data quite well, but also it's much easier to set up if you want to create a more complicated model. Then there's just more data to manage. It's not that it's not possible. It's obviously quite straightforward to do, but it is more complex to manage. So I mean, what this graph is telling me, I've got Excel to very nicely print out the equation that this trend line has used. So what this is saying is that for the x values, which are the temperatures, so for a 1 degree change in temperature, I'm going to get a 6.5168 change in position. The other thing to note is that increasing temperature results in increasing focus of position, which means it's focusing further out. So what I would do is I would take the results of this trend line, the 6.5, I would go back into Ekos. I would go to the filter settings and I would change this to 6.5. Now, you know, I would need to sort of copy this down to all of the other filters, and that is pretty much how I manage my real life rig. I'm just going to put this back to 10 for the purposes of this demo because it makes the maths easier. But that's kind of it. So what I would suggest, if you want to dip your toe into it, would be have a look at the that autofocus .txt file for your previous imaging session. You can start with one session. You can just basically look at all of your focus runs. You probably need to, as I've done here, filter it for whatever filter you predominantly use for focusing. So in my case, that's my luminance filter, and you'll get you can get yourself a simple equation as to how your focus position varies with temperature. And then you can collect as much or as little data as you want. Obviously, it will be more accurate the more data you collect. We tend to obviously round out the noise a little bit, but it will get you going. So it's not super difficult to get going, but you do need to maintain it a bit. The other thing I would say is that if you are going to sort of keep track of this sort of data, what you will need to make sure is that your filter, your focuser is going to be focusing, is not going to be drifting. So you can't have a situation where, you know, every time you focus, you drift out 100 ticks because of, you know, some uncorrected backlash, or something is slipping in the focus mechanism, or whatever. If you have that situation, then clearly graphing these things is going to give you a nonsense result. So you have to have predictability with your equipment before you can use this. So, you know, that's just a point to be aware of. Okay, so we've set our filter settings pop up with the data that we want, and I suppose the other thing to note in my simulator environment, the last successful run of luminance was at 2 degrees centigrade, and it solved at 36734, which is here. So what I'll do is, I've got a very simple sequence here that I just set up. So I'm just running 5 60-second luminance subs. I have adaptive focus set on, and I'll just start it up. So the first thing it's going to do is see if it needs to adjust its position based on temperature and altitude. If you remember, we set the altitude ticks per degree altitude to 0, so it's never going to adjust focus position based on altitude, so that's okay. Because the temperature was at 2 degrees C and it's still at 2 degrees C, then the temperature's the same, so it won't have adjusted the focus point for the first sub. So it's ticking away. It's got 15 seconds to go. I think not much is going to change for this sub either, so I'd expect another line here saying adaptive focus has run and it's done nothing. Okay, so there we go, another line's come in, and it hasn't adjusted anything. So what I'll do now is I can set the temperature. So I'm going to set it from 2 to 3 degrees. We can see back on the focus tab, temperature's now gone to 3 degrees. It's up 1 degree since the last autofocus run. So what I would expect to happen now is that when adaptive focus runs after the current sub completes in 20 seconds, I would expect it to go to the filter settings pop-up, get that 10 ticks per degree C change, and adjust the focus position outward by 10 ticks because I've gone up a degree C. So we'll see what happens. Okay, so it's moved from 36734 to 36744, so it's gone out by 10 ticks, which is what we were expecting, and you can see the focus position here has moved out. I've got overscan on, so it's gone out by 110 and back by 100, but that's just a bit of complexity. But so it's now moved, the point is it's moved the focus point out by 10 ticks for the next sub, which is now running. So if I go to say 2.5, you can see the temperature's now dropped half a degree to 2.5, so it's still half a degree up since the last autofocus run, but it's half a degree down since the last adaptive focus run. So what I would expect this time is I would expect the focus to come back in by 5 ticks, so it should go to 739, and as if by magic it's moved the focuser back to 739 for the next sub. So that's pretty much it. if you want to turn adaptive focusing on or off whilst a sequence is running, you just turn it off or turn it back on, and it'll just take the current setting when it executes the check if it needs to do something. So if you didn't have it set up and your sequence is running, you can always just turn it on, and that should be fine. On adaptive focus, how do you actually know whether it's done what it should, and how can you kind of get a bit of a feel for it? Well, the information is sent over to analyze. This is an analyze session of actually what I was imaging last night with adaptive focus on. So what I've got here is in this sort of stats section, I've just got the temperature and the focus point highlighted. So you can get a bit of a feel for how they're moving, and obviously they should be kind of moving together. So if I just, let's say, go over to here. So you're probably familiar, you can see, if you click on one of the focus items, you can see some details of the focus run, and you get a view of the curve. With adaptive focus, you also get these, they're a bit hard to see here, but if I zoom in a bit more, you'll get to see an adaptive focus. So here's one, for example. So if you click on that, what you can see in this panel is a bit of information. So it's telling you that the temperature had moved, and the position had moved in by 2 ticks based on the temperature change. I don't have altitude set up, so 0 for that, so total move of 2 ticks inwards. So you can keep an eye on things with that, and what you sort of expect to see is as the temperature moves, what you're expecting to see is, for your equipment and how you've configured adaptive focus, you're expecting it to move in a consistent way with that. One of the things I do sometimes is what you would sort of expect is where the temperature, for example, has fallen, between autofocuses. What you would like to see is the actual focus position sort of getting close to or moving consistently with the temperature, such that when the next autofocus run actually triggers, it's solving to a position that the focus had moved to through adaptive focus, if that sort of makes sense. So for example, if we were if we started off solving at 100, and we, as temperature moved down, we went down to around 90. If you solve again on the same filter, what you'd like to see is the autofocus solution being around 90, because that then gives you confidence that the adaptive focus is set up correctly and it's doing what you would expect it to do. And it's quite useful to look at this stuff because it gives you some confidence that adaptive focus is doing what it should do, and then that would facilitate reviewing whether or not you wish to refocus as frequently as you currently do, or if you wanted to trust adaptive focus a little bit more and refocus a little bit less. So you can have a play around with the analyze module, and hopefully get a little bit confident with adaptive focus. Mentioning is what equipment do you need in order to run adaptive focus? So for the sort of altitude, you don't need anything. Ekos will supply via the mount the altitude, so that's not going to be a problem. For temperature, you do need some sort of temperature source. Obviously, it needs to be somewhat reliable. Otherwise, you'll be moving based on incorrect information. The other thing would probably be, where do you put the temperature source? You'd probably need to keep it somewhere where it's exposed to the environment that the telescope's in, but not, for instance, near a source of heat. So, for instance, if you have an onboard computer that's that you fixed onto your rig, you probably don't want it near there. So basically, it would need to be somewhere where it's going to be exposed to the temperature that is going to be the environmental temperature for the rig, and that should be good enough. I suppose future developments, talked a little bit earlier about potentially making the algorithm more complicated than a simple linear approach, which is quite sensible if anyone's interested in that. I suppose the other thing would be around the temperature source. My temperature source seems to be quite reliable in that individual measurements don't seem to have too much noise associated with them. I was thinking originally what I might need to do is average, a number of measurements rather than rely on an individual one, but that doesn't seem to be necessary. But obviously, if anyone's having problems with that, I could probably put some functionality in for that. The other thing would probably be to kind of think about this, and I don't really know exactly what the solution would be, but happy to start a debate with people who might be more knowledgeable than me. But for folks with quite big telescopes, I suspect thermal equilibrium is a problem, whereby the scope itself takes a while to move to the ambient temperature, and if the ambient temperature is moving, it's always playing catch up and never quite gets there. I don't think I really have that because my scope's not that big, so it's probably not a problem, but it may well be that folks do have that sort of issue with some of the bigger pieces of equipment. So be interested if anyone is having an issue with that, and maybe we could start a thread. To some degree, if your modelling is always consistent, so if your temperature drops consistently through the night, and if your temperature source is actually slightly different to where your rig is because it hasn't reached thermal equilibrium, providing it's consistent and the measurements and the calibration should work. Where it won't work so well, I suspect, is, for instance, if you happen to live somewhere where you have, for example, a drop in temperature at the start of the imaging session, followed by an increase. So you're, for example, approaching 15 degrees C from both above and below. I suspect if your scope is lagging because of thermal equilibrium, that may produce some strange results, but I'm sort of speculating a bit. But anyway, if anyone has any thoughts on that, then it'd be great to hear about those, and maybe we can start a thread and potentially think about how we could do something for that. Anyway, I hope this has been helpful, and give it a go.